Hello, this is your video for Chapter 1 of Statistics on data collection. The first section we're going to talk about in this chapter is Section 1.1, Introduction to the Practice of Statistics. The definition from your textbook for statistics is that statistics is a collection of methods for planning studies and experiments, obtaining information, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the information obtained. In addition, statistics is also about providing a measure of confidence in any conclusions we might come to. Now, the information referred to in the definition is data, and data is simply observations, things like measurements, survey responses, and so on, that describe the characteristics of an individual. In statistics, when we talk about an individual, we don't always mean a person. It depends on the population that we're studying. We may be studying a population made up of people, and in that case an individual would be a person. But we may be studying a population of fish in a lake, and in that case the individual would be a fish. Or we may be studying a population of businesses, in which case our individual would be an individual business. So when we talk about a population, this would be the entire group that we're interested in finding out information about. So this is going to be usually some type of large group, and for the most part it's going to be too expensive or too time consuming to get information about the entire group. So if that's the case, we select a small group out of our population, and that's called our sample. So our sample is a subset of the population that's being studied. And again, our population is made up of whether they be people or objects or animals. So we have our population, which is the large group. It's made up of individuals. And then the sample is a smaller group that's selected from the population. Now, when we're trying to identify populations and samples, here's some key concepts. If we're talking about a poll or a survey, the sample is the set of all those that were surveyed. The population is always a larger group than the sample. And if the sample is chosen from a group with specific characteristics, then the sample can only represent a population with those same characteristics. For example, if the sample is selected only from U.S. citizens, then the population represented by the sample can only be U.S. citizens. It can't be all people in the United States, since there are people in the United States who are not U.S. citizens. Here's an example. A Nielsen television survey of 4,000 households in the United States finds that 2,988 of them watched the final episode of American Idol. Let's identify the population and the sample. The sample, again, is going to be all of those who were surveyed. So this would be the 4,000 households that were surveyed. Notice, again, this includes all of those surveyed, not just the ones that watched American Idol. So the 2,988 number in is data that we collected from our sample, but it is not the entire sample. Now, the population represented by this survey is all households in the United States. In this case, our individuals are households instead of people. So the population that's represented is households in the United States instead of being people in the United States. And also, the sample doesn't represent households in other countries because we only selected from households in the United States. Here's another example. A newspaper article reports that the president's approval rating is 33%, according to a Gallup poll of 1,022 adults in the United States. So again, if we want to identify our sample, the 33% is data that comes from our sample, but that's not our entire sample. our sample would be all of those who were surveyed, so it would be the 1,022 adults. The population represented by this survey would be all adults in the United States. Again, that's who our sample was selected from, so this sample does not represent all people in the United States because children weren't included in the selection process. Also, it doesn't represent adults in other countries because, again, the sample was only selected from adults in the United States. Now, sometimes we can obtain information about the entire population, and in this case, instead of being called a sample, this is called a census. It will be very important in later chapters in this course to distinguish between samples and populations and between statistics and parameters. When we talk about a statistic, it's some kind of numerical measurement that we calculate from our sample data. So it's going to describe some characteristic of our sample. So sample and statistic go together, and notice that they both start with the same letter S. If we have a census and we can collect information about the entire population, then any numerical measurement that we get from the census is called a parameter. So a parameter is some type of calculation that gives us a numerical measurement describing a characteristic of a whole population instead of just describing the sample. So population and parameter go together, and notice again that they both start with the same letter P. So if you're trying to remember which word goes with which, just remember that sample and statistic both start with S, population and parameter both start with P. Here's an example. Suppose the percentage of all students on your campus who have a job is 84.9%. Well, here we have a numerical measurement, so we want to determine whether this is a statistic or a parameter. Since this came from data about all students on your campus, that would be coming from a population. So that would make this number, the 84.9%, a parameter. Now suppose we have a sample of 250 students, and from this sample we find that 86.4% of our sample have a job. Well, again, we have a numerical calculation that gave us the 86.4%. That was determined from the sample data, so that would make the 86.4% a statistic. There are two major topics in this course when we're talking about statistics. The first one that we'll talk about in the first few chapters is called descriptive statistics. This just consists of organizing and summarizing data. We'll do that using numerical summaries, tables, and graphs. In the second part of the course, we will talk about inferential statistics. And this uses statistical methods that take results from a sample and extend them to the population. We also have some methods to measure the reliability or the confidence that we have in our results. The list of observations a variable assumes is called data. For example, while gender is a variable, the observations, which would be male or female, are actual data. So the first type of data we're going to talk about is quantitative data. And quantitative data always has to be numerical. So this gives us a numerical measure of some characteristic of an individual. We can do arithmetic operations, addition, subtraction, multiplication, and so on quantitative data. And when we do that, we get meaningful results. Some examples of quantitative data would be the number of students taking math courses at ACC this semester, or the ages of hospital patients. The other type of data is qualitative, or sometimes we call this categorical. This gives us a classification of an individual based on some characteristic. In other words, it puts the data into categories. So qualitative data may be in numerical form or it may not. Some examples of qualitative data would be the genders of professional athletes. So we can separate that into two categories, male or female. The rankings of college football teams. Again, we can separate into categories depending on the rankings that they have. And age categories of hospital patients. If we ask them which category they're in, under 18, 18 to 35, 36 to 54, 55 and over, that makes it a qualitative variable or qualitative data instead of being quantitative. Remember back here we were saying that the ages of hospital patients was a quantitative variable. That would be if we asked each patient their age and they just gave us a number. Whereas qualitative would be if we asked them which category of age they were in. So anytime that you are putting values into categories, that makes it a qualitative variable or qualitative data. Section 1.2 talks about observational studies versus designed experiments. So first we have to define some terminology. An explanatory variable is one which may be used to explain or predict changes in the values of another variable. It's often called an independent variable or a predictor variable. In other words, this is the variable that if we were doing an experiment we might try to change and then see what the effect is on other variables. So a response variable is one for which the values change in response to changes in another variable. This is often called a dependent variable. An observational study measures the value of the response variable without attempting to influence the value of either the response or the explanatory variables. In other words, in an observational study, the researcher simply observes the behavior of the individuals in the study without trying to influence the outcome of the study. If a researcher assigns the individuals in a study to a certain group, intentionally changes the value of the explanatory variable for the different groups, and then records the value of the response variable for each group, then the researcher is conducting a designed experiment. So the real difference between an observational study and a designed experiment is that in an observational study, researchers are just making observations without trying to influence the outcome. In a designed experiment, the researcher is trying to find out something by actually changing explanatory variable for different groups or different individuals. Here's an example. Some researchers wanted to investigate cancer risk among Danish cellular phone users who were followed for up to 21 years. To do this, they kept track of over 420,000 people whose first cellular telephone subscription was between 1982 and 1995. In 2002, they recorded the number of people out of all of these who had a brain tumor and compared the rate of brain tumors in this group to the rate of brain tumors in the general population. Our first question here is, was this an observational study or an experiment? In other words, did the researchers try to apply a treatment or apply something that would change the explanatory variable? No, they didn't. All they did was make observations. Notice here it says they just kept track of these people who had their first subscription between 1982 and 1995, and then they recorded how many of them had a brain tumor. So all they were doing was observing. That would make this an observational study. The next two questions we want to answer are, what would the explanatory variable and the response variable be? Well, the explanatory variable would be their amount of cell phone use. The response variable would be whether they ended up with a brain tumor or not. Another example along these same lines, this is still talking about cell phone use and brain tumors, but in this case the researchers used rats. So the rats in group 1 were exposed to one level of cell phone, one level of radio frequency radiation. The rats in another group were exposed to a different level of radiation, and the rats in the third group received no radiation at all. The rats in all three groups were treated the same except for the radio frequency. So was this an observational study or an experiment? In this case we had the three groups and the explanatory variable was varied according to which group the rat was in. So this would be an experiment. So in both of these studies, the goal was to determine if radio frequencies from cell phones increase the risk of contracting brain tumors. In both of them, whether or not brain cancer was contracted is the response variable, and the level of cell phone usage was the explanatory variable. So often in research, we want to determine how varying the amount of an explanatory variable affects the value of a response variable. Now, a lurking variable is an explanatory variable that was not considered in a study, but that can affect the value of the response variable in the study. Lurking variables are usually related to explanatory variables considered in the study. Here are some more examples. In each of these, we're going to determine whether the study is an observational study or an experiment, and we'll identify the explanatory variable and the response variable. So in this first one, researchers wanted to assess the long-term psychological effects on children evacuated during World War II. They obtained a sample of 169 former evacuees and a control group of 43 people who were children during the war but were not evacuated. The subjects' mental states were evaluated using questionnaires. It was determined that the psychological well-being of the individuals was as adversely affected by evacuation. So, was this an observational study or an experiment? All the researchers did in this case was collect data and make observations. So this would be an observational study. The explanatory variable would be whether the person was evacuated or not. And the response variable would be the psychological well-being. Another example, xylitol has proven effective in preventing dental caries or cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. Overall, the children preferred the milk flavored with xylitol. This would be a designed experiment because the researchers were actually intentionally changing the values of the explanatory variable instead of just observing. So the children were given a type of treatment. The explanatory variable here would be whether the milk had xylitol or not. And the response variable would be the evaluation of the taste. So whether the child liked the milk with the xylitol or not. Section 5 in this chapter is bias in sampling. So if the results of a sample are not representative of the population due to the sampling method, then the sample has bias. And I make this distinction where we say because of the sampling method, because it's totally possible to do everything right with your sampling and still get a sample that doesn't really represent the population well. That's just because sampling is always a matter of chance. When we're selecting a random sample, that means that it is random, and you can get samples that are extreme in that they have an extraordinary number of one segment of the population and maybe none of another segment of the population. So 3 sources of bias. 1 is sampling bias, 2 is non-response bias, and 3 is response bias. Sampling bias means that the technique used to obtain the individuals to be in the sample tends to favor one part of the population over another. So this is something that was wrong with your sampling method. Samples have to be carefully selected in order to get something that's representative of the population. Making claims about a population based on a sample with missing data is a common error made in statistics. Here's an example. A newspaper article reported that a majority of Americans disapproved of the war in Iraq, according to a poll conducted by calling phone numbers selected at random from 10 major metropolitan areas. The sampling bias in this example, there are actually at least 2 different things that we could talk about. One was this was done by calling phone numbers. That means that someone who didn't have a phone or whose phone number maybe was unlisted would have been left out. The second was that the phone numbers were selected at random from 10 major metropolitan areas. That means that a large segment of the population was excluded. Anyone who wasn't in one of those 10 metropolitan areas would have been excluded even from the selection process. So this sample had missing data. It would not be representative of all Americans. It would only be representative of Americans in those 10 major metropolitan areas who had phone numbers that were listed. Another type of bias is non-response bias. This exists when the individuals selected to be in the sample who do not respond to the survey have different opinions from those who do. One way this can happen is, for example, if surveys are mailed out and a large number of people don't respond to the survey or don't mail them back in. Now there are ways to improve this. For example, if you're making phone calls, you can call people back if they don't answer the first time, or you can offer rewards or incentives for people to actually respond to the survey. Another thing to be careful of with this type of surveys is if you have a voluntary response sample or a self-selected sample. This is one where the respondents themselves decide whether to be included. People who do respond to this type of survey tend to be those with strong opinions about the issues involved. In other words, if you don't care much about the issue, you're not very likely to take the trouble to respond. Here are some examples. A survey published in a newspaper where respondents must visit a website, call an 800 number, or mail in a form to participate in the survey. Again, the people who are likely to respond to this type of survey are those who have strong opinions. And you see voluntary response surveys a lot. They're common in magazines and newspapers, television, on the internet, but the results from these type of surveys are not statistically valid. They are extremely biased. A response bias exists when the answers on a survey don't reflect the true feelings of the respondent. Some types of response bias: one is interviewer error, another one is misrepresented answers, a third is the actual words used in the survey question, and for this, survey questions can be deliberately worded to encourage a specific response, often by using words that are emotionally loaded. And a fourth one is the order of the questions or the words in the question. This can affect the likelihood of a certain response. Here are some examples. Loaded questions: do you believe that gun control laws which restrict the ability of Americans to protect their families should be eliminated? So here, some of the emotionally loaded words are restricting the ability of Americans to protect their families. That's a very emotionally loaded topic. Also in this question, the fact that the question only really gave one choice. It asked if gun control laws should be eliminated. It didn't even name the other choice, which would be to keep the gun control laws. Here's another question. Should big oil companies be allowed to bribe our senators and representatives with campaign contributions? The fact that the question talked about big oil companies, that's a slightly emotionally loaded term. And then the word bribe, that's very emotionally loaded. So you would be much more likely to answer no to this question than to answer yes. Now we can also talk about the order of words in a question. Here's a question stated two different ways. Do you believe that gun control legislation should be repealed or upheld? Or do you believe that gun control legislation should be upheld or repealed? Now there might be a slight difference in how people would answer the question depending on which order the words were stated in. A lot of survey companies actually will randomly change the order of the words for all of the different surveys they put out, just to avoid any bias like this. The last section in this chapter is about the design of experiments. So an experiment, again, is a controlled study conducted to determine the effect of varying one or more explanatory variables or factors, what effect that has on a response variable. Any combination of the values of the factors is called a treatment. The experimental unit or subject is a person, an object, or some other well-defined item upon which a treatment is applied, and a control group serves as a baseline treatment that can be used to compare to other treatments. A placebo is something like a sugar tablet that looks, tastes, and smells like the experimental medication. Blinding refers to non-disclosure of the treatment an experimental unit is receiving. So a single blind experiment is one where the subject doesn't know which treatment he or she is receiving. And a double-blind experiment is one where neither the subject or the researcher knows which treatment the subject is receiving. Here's an example. The English department of a community college is considering adopting an online version of the freshman English course. To compare the new online course to the traditional course, a faculty member randomly splits a section of her course. Half of the students receive the traditional course and the other half are given an online version. At the end of the semester, both groups will be given a test to determine which performed better. So first, who are the experimental units, or the subjects? Well, those would be the students. What is the population for which this study applies? All students who enroll in the class. And what are the treatments? This would be traditional instruction versus online instruction. The response variable would be the exam score for the test that both groups are given at the end of the semester. Last question is, why couldn't this experiment be conducted with blinding? Well, both the instructor and the student are going to know which type of instruction they're getting. So both of them know which treatment they're receiving.